Okay, so we're going to do our first case study, and we'll keep coming back to this one, which is the Beetles case study. So let's head over to R, and let's do some setup. So first of all, we're going to read in our data and have a look at it. So each row is an experiment. So this is grouped data, because what we've done is we've got the concentration, how many beetles were exposed, and how many died. So we've grouped it together. And that will be important later when we look at our logistic regression. Next thing, let's do a quick skim, bit some EDA and see. So we've got no missing data, it's all complete. And we've got our concentration, which goes all the way from 1.69 up to 1.88. Our exposed, and what does that go? That goes from 59, the most we exposed was 63, and dead goes all the way from only 6 died all the way up to 61 died. What I'm going to do here, so we can visualize it, is I'm going to add an extra column. And what this is all I've done is I've calculated the proportion of beetles that died. So only 10% roughly died, an exposure of 1.69, but once we're up at 1.88, we get an exposure of 1. And then we're going to plot this. We're going to put concentration on the x-axis, proportion on the y-axis. We're going to add some points. And I'm going to add a geom smooth, but this time, instead of we've used before LM, I'm going to do a GLM, which is the function we're going to use to fit this model. And also I've told it that we're doing a binomial, so that's going to add me a logistic regression curve, which is this. So there's a nice curve for us. We can see as concentration increases, the probability of death increases as well. So how are we actually going to fit our logistic regression? Well, because we're now doing a general linear model as opposed to a linear model, the function is ln, but you put a g at the front. Now there's two ways you could do a logistic regression. If we had for each beetle the concentration and whether it died or not, that would, each row now would be an individual beetle, we would just give, outcome on this one. But because it's grouped, because we've grouped altogether, say 60 beetles at a time, and they all had the same concentration, what I need to do in this is I have to use the formula that will let me put in groups. And what this is on the left, as always, is our information about what we're trying to predict, which is our probability of death. And what it wants is basically wants a matrix with two columns. The first column is your successes, which in this case is dead. And your second column is going to be your failures, which in this case is going to be our exposed minus dead. So what we created here is we've created a response variable that is a matrix with two columns, success and failure. And our predictor is concentration. We say where to get the information, as always, beetles. And then what we need to do is we need to let it know what type of general linear model we're doing. In this case, we're doing a logistic regression, which means that we're trying to model it with a binomial. And the way that we're linking our slope and intercept and concentration to our probability, in this case, is by using the logit. So we run that. And now if you look at the summary, you'll see that it looks quite similar to our old linear regression. That's what it's designed off. So here we've still got an intercept. We've got a slope. We've got some extra stuff here. Null deviance, residual deviance, which we'll look at later. We've got Z values as opposed to T values. And we've got what looks like a probability. But again, we're going to come all back to that next week. But here is the intercept and here is the slope. So we're saying the logit of the probability of death equals minus 60.556 plus 34.146 times concentration. So that's what we're going to do. I will keep coming back to this example. We'll build up and we'll start looking at the rest of this and interpret it. Okay, see you next time.